The purpose of this video is to try to give you an example of going from a whole bunch of data that's kind of a mess to actually testing a hypothesis. So what you see in front of you is some data I have been messing with for a number of months on this is on university composition. So I downloaded a bunch of data from a bunch of different universities, and what I wanted to do was look to see if the composition of adjunct versus full-time faculty members had been changing. So basically what you're looking at is sort of a mess of data where I've gone about trying to generate student credit hours per faculty member and then the percent of the faculty that are adjunct. So it doesn't necessarily matter, but I just want to show you that first of all, my data is a mess, probably like you feel like yours is. There's missing data that's going across the page and not up and down, but I want to get this into testing a hypothesis. So first thing you got to do is figure out what you want to test. So in my case, what I want to test is to see if the composition is changing over time. So the first step I had to take was I had to divide up my data into groups, because I can't put 77 different data points on one line. That's going to just be a big mess. So I generated these groups of small, medium, large, and then extra large units. And once I got that done, see all the holes in the data? I went on over to this next page and notice the holes are gone. Now, how did I get rid of the holes? What I did was I took an average of the previous and the next data point. So this one right here, for example, is a combination of what happened here in 2001 and what happened in 2003. So I added the two of them, or I took the big one, subtracted the smaller one from it, divided that difference by 2, and then added it back to the lower one. So you can see here how the cells work. So it kind of gives me a point in between this one and that one. And I did that, and went around and I filled all these holes in on my data all across my spreadsheets here. So as you can see, I have now lined up all the data into these groups of small, which is 1, and then medium, which is 2, and large, which is 3, and then down here at the bottom I have extra large, which is 4. Now this data may look familiar to you because it's the data that we used in class. I had changed the names for you, but nonetheless. But now you see that it's all running across the page, and it's also intermixed. I've got numbers, and then I have percentages and numbers and percentages. So now I need to transpose all this data so that I can run my regression model. So I'm going to take my data and cut and paste it to a new page. But before I do that, I'm going to name this page cleaned data, and then I'm going to copy the whole thing by going up here to this upper left hand corner and clicking there, and that highlights the whole sheet. And I'm going to Control C it and then go put it on another sheet. So now I have all my data here, and I'm going to rename this as data for transpose. And now I have to figure out how to switch it all on its side, because it isn't useful to me like this. So I have to separate it and transpose it. So the first thing I need to do is rearrange the data. If you notice, it goes from number to percentage, and number to percentage, and number to percentage. So we're going to highlight all of this data that we want to switch, and I'm going to go here to sort, and I'm going to go to options, and I'm going to click on this button, sort left to right. And when I sort left to right, I have to pick a row that I want to sort by. So I'm going to pick row number 3 right there, because I want all my numbers and then all my percentages. So I'm going to sort largest to smallest, and I want the numbers first and then the percentages, and it should move it all for me, and it did. So you notice I got to 2012. Now I got a little problem with my numbers here, and I can't just sort all those until I separate out my percentages, because if I resort it, then they'll end up back intermixed. So I have to do something here to change the way my headings are. So, and all I really care about at this point are these averages that I've created, but still, I think it is useful to show you how to do this. So it should all be in exactly the same order. It won't it won't mix up the columns. So this is all 2012. So we just need to rename it. So if I would have changed the names ahead of time, I wouldn't have to do this, but I need to because I didn't change the names ahead of time. So once you get them recoded like I did here, then you can just highlight them again. Over here I already did those, so I'll just do these, and you can do the same thing. So you go to data or sort, and then options, sort left to right, and then we're going to sort it by the top row, and we want it to go smallest to largest, and then it will just rework them all the way over. Okay, once you have that done, now we have to actually transpose the data, and since I'm really only interested in using these averages, then I'm just going to pull out the averages. Now, I don't care about these different schools, so as long as I have all this pasted in here as values, which I do, and you can check that by clicking on it and making sure you have a number there, I can get rid of all of this. I only need just the averages, and so I have it written in there, average small, and then I have average medium. So I can just get rid of this, and then I can get rid of all of this. And all the way down the page. So now what I'm going to do is just highlight one of the sections here. So I'll start with this top, the small schools, and just go across like this, and I can include the years on both sides. I just happen to have them on both sides because I've been playing around with this, but I control C it, I bring it down here, right click, and then see that little thing that looks like a Tetris? You just click on that, that's transpose. And so you can see I've got all the averages for small for all the years, and I have the variances for smalls for all the years if I want those as well. And I'm just going to do that for each of these. So I'll copy this, I'll bring it down here, I transpose it. Here's my medium, and my large, or big I guess I've called it. And then I might just go through and clean it up because I got all these years and I don't really want that. So I just delete that, highlight it, and hit delete. And then I need to do the same thing with my percentages because I need both of them for what I'm doing. So I'm just going to go do the same thing. So now I have them all over here and I have them all lined up. So now I can go about the business of trying to test what I need to test. Okay, so I ran my first regression, and this is on the percentage of adjuncts. And whether or not it has changed over time. So my null hypothesis is going to be something along the lines of beta naught, or beta 0, is equal to 0. And then the alternative hypothesis is going to be so my hypothesis I was interested in testing is something along the lines of beta naught is equal to 0, beta 1 is equal to 0, or beta 1 is not equal to 0. So if the composition of adjuncts at universities had not been changing, then we would not see a slope because we would not see a relationship over time with the percent of adjuncts. But if it has been changing, then we would see a slope. So we look down here at our output and we see that our x variable has a really small coefficient, but that's because this is in percentages. but we can tell by the t-stat and the p-value, see these two right here, that they're significant, that they matter, that they are changing, and we can see that the slope is increasing over time. That's the percentage of adjuncts at small schools. We can also look at the student credit load per faculty member right here. See how these are in numbers? So we can run the same regression. So we just do data analysis, regression, and now we are still going to have the same x range, which is just time in this case, but we're going to put the student credit hours there, and then we'll put our output right here below this one. And here we're going to see, again, not quite as significant, not as clear, but still significant. We can see that we have a p-value that tells us it's significant. It's not all a bunch of zeros though, so that's okay, but we have a t-stat of 2.3, so again, good enough for us to say that indeed the composition of the student credit hours per faculty member is also increasing. So another way to do this is to graph it so we can kind of look at the results or the relationship. And so we can highlight the years and the student credit hours right here, and we just go to insert and we put a graph right there, and there you can see, right, you can see how it's changing over time, but we didn't put in the percentages. So if we forget those and want to add those in, we can just grab that box and drag it over, and then it's going to add them. But you notice that the percentages are so small that they're not going to matter. So instead what we want to do is format this and put those on a secondary axis, because then we can actually see them. And then of course we want to change this so it makes our point a little bit better. So we go over here and we want to have the lowest number maybe 300, with the top number 600 is okay. And then with this one here, with the student credit hours, we want to change that sort of the percent of adjuncts. So we maybe want to start with, say, 5%, oops, 0.5, and we want to go to maybe 35 is okay. Oops. Could be 5. And then if we wanted to, we could also insert the line just so we can see it. That's going to be our blue dots, and then our adjuncts will be on the other one here, and we can add the trend line here. And depending on the scale we put this on, it's going to change the slope of that line. It went back to something, so we want to change this to like 0.2. Oh, maybe that's too low. Anyways, you get the idea, right? So now we've got a graph and we've got some regression results that sort of support what we're thinking. And so in this case, we would be able to write something along the lines of, so as a starting point, you might want to say something like this. Using a regression model, the study was able to determine if there is a statistical relationship between time and faculty composition. As can be seen on these results of this test, over time we can see that the percentage of adjunct faculty as a percent of all faculty is increasing, as are the student credit hours per faculty. And then we might just go on to say something like, specifically for each 1 unit increase in time, we see the percent of adjuncts as a part of the entire faculty increase by 0.09%. This coefficient is statistically significant and it is unlikely that it would have occurred by chance. I didn't have that in there, but so let's just take a step back here and take a look at what we have found. Sometimes when we run the regression, some of the output can be, a little, okay, so what does this exactly tell us? I tend to like to use this interpretation that for each 1 unit increase in the x variable, whatever that is, time in my case, we see a coefficient increase in the y variable. So another one in this little practice problem here, or whatever, my little research study, Another one we can use is this one, and I think this one is even a little easier to understand. Additionally, this research suggests that for each 1 year, we can see this number of student credit hours per faculty increase by about 4.5. Again, this coefficient is statistically significant, suggesting that it is unlikely that these results occurred by chance. So we see that right here, where we have this coefficient of 4.5. So just the way I ran the regression, I did it over time. In this case, I don't have, it's a very simple model. I've got time and the number of student credit hours per faculty here, and then the percent of adjuncts here. And this is for the small schools. And, of course, I would do this for each of the different schools, school categories, and, sort of look at it, all together. But hopefully this gives you just a little quick example of kind of how to flip the data around, how to run the regression, how to graph it, and you can use this maybe to help inform your study. So I hope this was helpful, and I will talk to you soon.